Welcome
to the joy of coding.
Hello, and welcome to episode 369 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. It's June 19th. Wow, we are cooking through 2024. Holy smokes. Let's start by sharing my screen. Yeah, it's June 19th, 2024. Like, we're basically halfway through the year. 6 months in. Wow, this year is just flying by with episode 369. You know what? I feel it was only yesterday I was being all smug about, we made 350 episodes. We're closing in on 400. I don't know when 400 will be. I don't think it'll be in 2024, but it might be early in 2025. And that'll be something. Pretty excited about that. All right. Welcome to the stream. I'm going to be live hacking on some Firefox stuff. It's so good to have you here. A reminder, no plan survives breakfast. I think I know what I want to do today. I think I know what we're going to be working on, but who knows what'll happen. I might get sidetracked, all sorts of things might happen. I might get stuck. That's okay. You know, you're watching me deal with stuff in real time as opposed to like working on anything kind of like pre-scripted. So that means that things might go wrong, and that's okay. And we'll just sort of figure it out together. That's the first thing. The second thing, I want to mention that the agenda, which I failed to export, I realized, the agenda that we're looking at is, in theory, available to you. Let me quickly make sure that gets synced. Yeah, it should now be available to you. The agenda has got all these handy-dandy links for you to follow along in the event that you want to, maybe you're interested in looking at this bug. You can click on that link and you could follow it along. And as I update the agenda, you'll see this little thing spin, and you should see if you refresh the page, you should see the change. So good. I've made sure that it is now posted. So the agenda is up. All right, let's jump right into it. I wanted to give a final update on a thing that we started, I think, late 2022, early 2023, and the story is finally over. And that is the Windows jump list stuff. You may, if you're a longtime watcher of the stream, you're probably sick at this point of hearing me talk about the Windows jump list. And I'm sick of talking about it, frankly. But basically, the TLDR is, for much of 2023 and some of 2024, we have been working on the stream. I have been working like only during the stream. So it was like an hour and a half every week on making the jump list implementation for Windows 10 and up. And the jump list is the thing that appears if you right-click on the Firefox icon in the Windows taskbar, making that work off of the main thread, because our old mechanism was doing it on the main thread, and that's not great. And that was very complicated, and like testing was very complicated. And we figured out a way of doing it and implementing it. And there were two implementations. There was like the legacy one and the new one, and we finally got the new one out the door a few months back, and that was great. And there were some bugs with it, but we fixed those bugs. We dealt with them on the stream. Someone on this stream actually reported a bug. I think it was Crushed Optimist reported a bug. We found it. We fixed it. We shipped that fix. That fix went out, I think, last week or the week before. That was very, very exciting. And then the last two chunks were like, we needed to make the favicon stuff work off of the main thread, which we did. We got, I think I got that stuff landed last week sometime. Favicon. It's right here, 1503809. Closed 7 days ago. So that closed last week. So that'll be in version 129. And then not long after that, at long last, I got rid of the old legacy implementation. So bug 1880109, this was the one where we finally landed the patches to remove the old main thread implementation of the jump list, and that's done. There was a one regression where I forgot there was some dead code and I forgot to remove some stuff, but I closed that out and it's done. You know, I'm going to quote Elijah Wood from I think it's Return of the King, where he was like, after he's thrown the ring into the lake of fire, he goes like, "It's done, Sam. It's done." And this was a long haul. normally I don't think something like this would have taken me a year and a couple of days, or a year and a bit, year and a couple months, year and a half, I guess. But a reminder, I was only working on it during the stream. So, you know, there's a lot of, if you only work on it for an hour and a half at a time, and it was like on and off, normally something like that would probably have only taken a few weeks, I think, instead of a year and a half. But I only worked on it during the stream. So I hope that was interesting. If you followed along for the entire journey, start to finish, you did it, you made it. And if you're curious about going through the whole saga, watch most videos from 2023. And you'll hear all about the jump list. You can see right from the very beginning me talking about this problem and dealing with it. Okay, so that's the final update on jump list. The story is over. Let's move on. Woo! So what do I want to work on today? Well, you caught me actually just as I was working on something. I think you'd heard me talk about some time for jump list swag. So Smurfy gives a woohoo, and I agree, woohoo. In fact, I think that that deserves some kind of like sound effect.
Oh yeah.
And
here we go.
Oh, or this one. This is a good one. All right, and Craig thinks that there should be jump list swag. I think that'd be pretty great. I don't know if anyone here has any drawing talent. I certainly don't. But feel free if you want to come up with some kind of sticker, and maybe we can pass those around and people can print those out of like off main thread. I'm trying to figure out what that would look like off main thread Windows jump list. Like, what does that look like? It'd be like, I don't know. There's some kind of visual pun that is suggested. I don't know. But feel free to create some swag. You know, there's I'm not in control of your destiny. You do it. Okay, so what am I working on? Right. So this is related to the backup mechanism that I think you heard me talk about last week and a couple weeks before that. And we've got this set of patches that allow us to encrypt and decrypt backups using a scheme that was developed in concert with our security engineering team. And, you know, our security engineering team, like any good security engineering team, they are, you know, very rigorous in the way they approach these things. Like, this is not a casual thing when we're talking about user data and encryption. Like, it has to be very carefully thought through. And so a lot of time was spent designing the scheme. And one of the things that they want me to do before landing is to account for something called a truncation attack. So in the event, when you create an encrypted backup, what we do is we generate this HTML file and we insert at the bottom of it a document comment, an HTML document comment, and we insert inside of that a MIME message, a multi-part MIME message, and that encodes a JSON block to describe the backup, and then a giant base64 encoded binary blob. And that's actually where the backup resides. It's a compressed, basically a zip file of the backup. And that set of bytes that is base64 encoded is encrypted before it is compressed first, and then it is encrypted. And we break up the encryption into blocks. There's a certain block size, or chunk size rather, and you encrypt one chunk size. This is so that you don't have to read the whole thing into memory in order to encrypt. Like, some of these backups might be dozens, maybe even 100, low hundreds megabytes, and you don't want to have to read all of that into memory in order to encrypt one of these things. And so we're doing it in chunks. We're encrypting about a megabyte at a time, and that's good. But because you're doing it with blocks, as soon as you have this sort of like streaming encryption or block encryption scheme, you run the risk of something called a truncation attack, where you can, if the mechanism is not prepared for the the last few items or the last item in the set of blocks to be removed, you can get into like an attacker who has access to your encrypted backup could like remove the last chunk or something and then put you into kind of like a broken state, basically. So they might not be able to necessarily access the encrypted data, but they could cause confusion during the decryption. And so what we want to do is in the event that the decryption fails at any point, we want to blow away any of the intermediate bytes that we've written to disk. And also, if the decryptor claims to have not decrypted the last chunk, we should also blow away the directory. Akris asks, is this feature also coming to Thunderbird? The Thunderbird team did reach out about that, and like in the future, that'd be probably pretty nice. I mean, I suspect that Thunderbird's databases are significantly larger than Firefox's. Like, I think mine are in the gigabytes in size. Like, I have a humongous inbox. Now, we're only developing this with Firefox in mind to start, but nothing will prevent us in the future from like backporting it to Toolkit or like uplifting it into the Toolkit and maybe having Thunderbird take advantage of it. There'd be quite a bit of work, I think, to get them to clone their data stores. Like what we had to do is basically audit the profile directory and figure out what things that make sense to back up and how to back them up. And the Thunderbird team would need to do something similar, and then implement support for that. But in theory, it's possible, but like not off the bat. This is just for Firefox to start. So I have been working on this bug. This is blocking a bunch of this stuff from landing. This is something that the security engineering team insists that we have done before we land any of the decryption stuff. Before we land any of it, is if the decryption fails at any point, either the last chunk is not reported to have been decrypted and somehow we're done, or if we if somehow one of the chunks doesn't decrypt properly, then we should just blow the whole thing away and report an exception. And so what I did was we can actually take a look at the patch I've got so far. So the way we're doing decryption and the way this is all working is, again, we're trying to avoid reading everything into memory. So we're using the Streams API. If you're not familiar with Streams API, it's fairly handy. It's a web API that's relatively new, but it's been in Firefox since, like, at least chunks of it, like Readable Stream, have been around for a while, like 65, version 65. 102. Like, this is not like cutting edge. And if you're familiar with like streams in other languages, like stream primitives like in Java or C++, the stuff that is offered by the Streams API is probably not too unfamiliar. It is it's one of those things where the web API has given us these sort of like primitive generic streamy things, and then you as the developer can kind of like specialize them to do what you want. And in this particular case, what I'm doing is like I'm using a transform stream to, when we're doing the decryption, to take in a stream of bytes, make sure that we get a block that is our expected size, and then base64 decode it, and then decrypt it, and then feed that into the next stream, which is a thing that's writing to a file. So what you're able to do with streams is you can sort of compose them. You can like plug one stream or pipe one stream into another. That's one of the nice things about streams. And so the long story, like the advantage of using streams is that you can kind of get this almost conveyor belt action through each of your transforms, so that you don't have to wait until the whole thing is decrypted before writing it to disk. You can like write it to disk as it's being decrypted, and one of the nice things about that is you don't have to hold the whole thing in memory. And that's good, because like I said at the beginning, this thing, what we're decrypting here could end up being in total like hundreds of megabytes large. You don't want to blow out the user's memory whenever this is occurring. And you could run out of memory. You could the user could need some of that memory. The drawback being that we have to destroy the file or any of the stuff we've written to disk if things go wrong. That is the trade that we need to make. Because like if we'd been holding it in memory and things go wrong, well then, you know, it's just in memory and that's okay. Like no harm, no foul. We didn't attempt to recover from stuff that wasn't blasted out to disk yet. But because we've written something out to disk, you might have like a semi-corrupted zip file that is not what the user expects, and you know, recovery puts you into this sort of like broken state, and we don't want users to ever get into that state. So that's the TLDR, is that we need to deal with truncation attacks. And the good news is that the Streams API allows, if you've got a whole series of streams, like transform streams and maybe you've got a whole series of transform streams all plugged together. If something goes wrong, you have access to something called a controller. The controller is kind of like the thing that is overseeing the streams. And the controller has a method on it called error. And if you call error on it, it'll basically tell every stream in the chain, like, we're aborting, like something's gone wrong. And you can, as a stream, you can choose to react to an abort. And in this case, the thing that is like writing the bytes to disk, I have added a handler for an error, which is the abort. And then what we do is we close the stream out. Anything that we've already written, we'll just close out the stream, and then we will remove the file. We'll just like blow it away. So that is the current approach. So we have a fix, and that abort will occur in the event that either decoding from the base64 decoding fails or decryption fails. Because if decryption fails, we'll throw an exception, and we'll blow it away. Now the other thing we need to account for is in the event that we somehow completed decrypting despite the last chunk not having been decrypted. That is something we need to avoid as well. I think that is something that our decryptor, I'm just looking through the implementation here. Oh, hello, Shearshack. Good to see you. This is the, let me pump up the font here. Whoops, that's too much. The archive decryptor, we initialize it, we decrypt. We need to ensure that the decryptor is done. What I'm going to actually do, I think, is I'm going to expose, there is an is done method on the decryptor, and I'm going to make it public. I think that's what I'm going to do. And then what I'm going to do is inside of the thing that uses the decryptor, which is the backup service, we have last chunk. What we need to do is see whether or not, like, process chunk sent all of its strings. Buffer. Basically, I think what they're asking me to do here is if this .decryptor is done, then we should error. Controller.error corrupted archive. I don't exactly know how to test this particular case because, like, this is, I wouldn't say it's tautological, but like we are telling, when we hit flush, it's because the stream before us, which is reading in from the binary blob, it's told us that the last chunk has come through. And so we tell the decryptor that that was the last chunk. So almost what we want, you know what it is? We want to do this outside of this. It's like the thing that is the decoder decryptor transformer, and the file writer. I think we also want the file writer whenever it calls close, we need to ensure that when we close that the decryptor was done. That's what they want me to do, I think. So I think we need the decryptor here as well. And this is of type archive decryptor. And then the constructor, whoops, this dot decryptor equals decryptor. And it might be null. And if we close, if this dot decryptor and not this dot decryptor is done, lazy log console error. Now what is the close? When we close one of these things, what is this? This is a writable stream. You construct one of these things and then close. This method will be called if the app signals is finished writing chunks of the stream. The contents should do whatever is necessary to finalize writes and release access to it. This process is asynchronous and return a promise to signal success or failure. It can clean up any... okay, so I think I believe we will end up inside of abort in the event that close somehow failed. Or close corrupted archive. And then we're going to say controller was close. It was gets the controller. Controller, that's a writable stream default controller. Controller for the writable stream. Okay, controller, and we're going to say controller.error corrupted archive. Corrupted archive, or rather what I'll say is decryptor was not done when the stream was closed. Corrupted archive. And then abort. We should end up over here. Now, I'm not entirely certain how to test this. Okris asks, if you're using streams, doesn't it mean you can have partially restored archive before encountering an error? Or do you plan to do multiple passes to make sure the archive is correct before actually doing restoration? Partially restored archive. Yeah, that's exactly what we're trying to avoid, a partially restored archive. We want it so that in the event that the archive file exists at the point of running through all of these pipes, or piping through all of these streams, that the decryptor reached the last chunk and that there were no problems base64 decoding or decrypting any of the chunks. That's what we want to ensure is true. Now I have to pass in the decryptor here. And what happens if I've got some tests here already. Let me just fail. What happened? Failed or it just failed for some reason. Unexpected exception object event. That's not helpful. Let's see if we can figure out what's going wrong here. Something in my implementation is going wrong. All right, pause on exceptions. Let's go. No? I thought it. All right, let's try that again. Let us set breakpoints on where we made some changes. Create archive. Create a worker. Construct the archive. That should have succeeded. I think creating the archive should succeed. No? All right, let's try that again. And the problem sometimes with this stuff is that our dev tools aren't super happy. Oh, yeah, it's like creating the archive is failing for some reason. Let's take a look at what we've done. I don't know what's happening here. The error messages I'm receiving are not... Oh, yeah, is done. Well, first of all, there are a number of places that call is done already that they're going to be upset about this. This is like not valid JavaScript because like I changed the name. I made that public. Yeah. Okay, let's try that again. Okay, that's better. And the tests pass. So that's good. Now, one of the tests that I just added was specifically testing the truncation attack. So what I do is I create an archive and I make sure that there are multiple chunks that have been encrypted. And then I reach into the file. After I close the file, I reach into it and it's pretty gross. I find the last line that's really long and I get rid of it. And then I join it back up and I blast that out to disk and I ensure that extracting fails. SmartD says, once you have decrypted and decoded, it could be worth doing something like tar, TVF, file tar, or zip to verify the archive. I think this is what Ocris meant. That is interesting. Does the zip, NSI zip reader.idl, do we have test the integrity of the archive before performing a CRC check on each item expanded into memory. If an entry is specified, the integrity of only that item is tested. If null, the integrity of all items within the archive is tested. That's not a bad idea, is to just test the integrity with the zip reader. Good idea. Let's put that. Where is the support for decompression? Zip reader? Oh, we don't do that in this patch. So later on, maybe. Let me add a bug. New bug. Simple file. Archive support. Run. run NSI zip reader test on the recovery.zip file before attempting to recover from it. According to the documentation, size zip reader, this will do a simple CRC check on simple CRC check on the archive. We'll want to CRC check the whole thing. Okay. All right. That's nice. Okay, maybe we can do that later. Let me do work on maybe. Okay. Next. Yeah, I think I showed you the test that I'd been working on. I'm trying to figure out how to test this. You know, the decryptor is done, or like, can we somehow cause the stream to finish before the decryption is done? Can I engineer that somehow? How would I do that? You pipe the archive stream through the binary decoder and then into the file writer. And close is called if the app signals it is finished writing chunks to the stream. Does the controller allow me to closes the associated stream? Piping the archive, we create a binary readable stream. Pipe through there, pipe to the file writer. Stream. I wonder if this could return the archive stream. What happens if I do this? No. Return archive stream, pipe through, pipe to. Returns a promise resolved and the piping process has completed. I suppose what I could do is I could export transform stream and writable stream. Create an instance of archive stream. If I make this public, my test could get one of these things. And then it could create archive file, start byte offset content type. That comes from sample archive, which is public. Okay, I've got an idea. Oh, Okra says, I meant something more subtle. Since the streams process data in chunks, you might be restoring data before encountering an error. You might be restoring data before encountering an error, so you'll have to either read whole archive into the buffer before starting restoration or do multiple passes, assuming archive won't change in the meantime. First pass to verify the correctness of archives. Oh! So, yeah, we don't start any restoration until the decryption has been completed and the chunks have been written to disk. That is the case. Like, we don't try to unpack it while the decryption is still underway. We wait until all of the decryption is done and all of the creation of the basically the recovery zip to disk is done, and then we unpack it and then we recover from it. So we do any of the like streaming to disk or like dealing with the large files, we do that in streams, but the actual steps are done in serial. Hopefully that makes sense. So here's my testing strategy for what I'm talking about here is, what if I create binary readable stream. This is extraction channel. If I make this public, create binary readable stream, and then in a test, let's try it, adding a new test. It'll be sort of similar to this test. I'm gonna say test that if the binary readable stream closes early before the last chunk is decrypted, that the file is never written to. How do we do that? I basically want to have the binary readable stream abort halfway through. How does that work again? Binary readable stream. Constructor start. On data available. We open a channel and we get data. This might not work. I'm just going to warn you all now. But let's try it. Early binary stream close. So we create some backup. We can probably just use the built-in. Oh, look, I don't need to write a fake compressed file. I can just use the fake compressed what is it? The fake compressed staging path. Sure. Which is what? That's, yeah, zip. Okay. Fake compressed staging path. We have some fake metadata. We don't need to do this anymore. We're going to sample the archive. We're going to get the starting byte offset content type. Okay, and then we are going to do this stuff manually. We're going to create create readable stream. We're going to need to create an archive file. The archive file is fake archive path. Archive stream, we create a binary readable stream. And then we pipe it through. We need a decryptor. We're going to create a decryptor like this. I think we have access to just archive decryptor, right? Did I? Service archive. I guess I didn't bring in the decryptor. Okay. I guess I will now. Archive decryptor. Oh, sorry. Archive decryptor. Initialize. Fake recovery code. We will need the archive JSON, I guess. Initialize the archive decryptor. Pass that in. We will need these things. The destination path. Let extraction path equal that. And then what we need to do is we need to ensure that the destination path does not exist when this is done. So let pipe promise equals that. And then we can await the pipe promise here, but what we're going to do is we're going to say archive stream.close. It'd be nice if we could go like, if we can incept a little bit. You know what we could do is we could put another pipe in between. Or we could put another transformer in between. So the archive stream writes into something which is designed to fail over fairly quickly, maybe after some number of bytes, and then it just closes itself. I kind of like that. Okay. So what I'm going to do, I need to get these. These need to be exported. Export class. And then file writer stream also needs to be exported. writer stream and decoder to printer transformer. Chrome utils, import ES module, resource modules, backup service. That's where those are. So we construct those things. Compressed file. We won't need to do that here. Okay. Let's just see what happens if I only run this test. I'm very curious. If you could somehow tell the stream its size, which is smaller than the actual file. Yeah, so that all worked. The stream extraction was not automatically destroyed because the whole thing went through okay. So what we need to do now is pipe the archive stream through something else that then goes through the binary decoder. So here's what we're gonna do. Pipe through early aborter. So class early aborter, or let early aborter equals new transform stream. And what that'll do is a transform stream. Transform stream has an async transform method. So it's going to controller enqueue chunk part. So it's just going to pass that through. But like, it's also going to have this like counter equals 0. This dot counter. Wait, can it do that? Counter. Oh, it's an object. Sorry. This dot counter plus plus. If this dot counter is greater than 3. Controller dot abort. We're done. Aborting early. Else. Do that. Early aborter. Okay, let's see what happens. So it wasn't automatically destroyed. Aborter. Are we actually in dump and queuing? Is that actually happening? Oh, there's only one. Right. Okay, we need a larger file. The compressed. We're going to do this again. There's only one block. Well, you know what we can do actually is transform. We'll send half of this first chunk and then we'll abort. So no counting. So controller dot enqueue the chunk part. I think it's a string. What we're going to get is a string from the archive stream. So we're going to take half of the string. So the way to do that, get half of the string. I think there's the dot substring. JavaScript, or what is it? A string dot prototype dot substring. We're going to go to chunk part substring 0 chunk part dot length divided by 2 will math floor, and then we'll abort. How about that? Controller dot abort. Oh, it's controller dot error. Error. Unexpected exception. We're done. Aborting early. So early aborter. We're gonna try this. So awaiting this should assert rejects pipe promise aborting early. Hey, that worked. All right. Now I want to make sure that the we're exercising the right part of this, which is the part that is called dot remove here, abort, writing to such and such failed. Yeah, failed. We're done aborting early. Yes. Okay, good. We did it. We did it. So we hit this part. That's what I wanted. It only meant that we had to like expose a number of things public or like for testing, but that's not so bad. I think initialize chunk size. I think this is a leftover. I don't need that part. Initialize. I don't think we need that anymore. We expose is done. We export that. Close the controller. Like we call close. Just decryptor. We abort. Before we were awaiting this, we are now returning it. I guess we can go back to what we were doing before. I think that should still be okay. And over here, we bring in all that stuff. We've written a couple of tests here. We need to document that early aborter, but White My Stick 1 asks, do you use AI to help code? Not really. Not really. I know some people who do. I know some people who seem to get some value. I've never, like, I tried it for a little bit, and I found that a lot of the code that it generated wasn't the best quality. Maybe it's gotten better since I last tried it. What else is there to say about that? I find that I have to spend more time double checking what it's written and ensuring that it actually does what it claims. At the time, I had to like spend a lot of time like reading what it had created. It was almost like I had to do code review for like someone who may or may not have been trying to confuse me, to make or take advantage of me, which is actually not that bad an exercise now that I think about it. Like One thing that I think would be very interesting for code generation, this is kind of goes back to something I talked to a friend about. So one thing that I used to do whenever I was in school is I'd have to write essays about some topic, usually in English class. And, large language models these days can pump out plausible essays fairly easily. And so teachers are like, what do we do? Is this the death of the essay? And I was talking to a friend who's a teacher, and one idea that we talked about was you actually take advantage of the fact that these things generate essays. You don't write essays anymore. You don't have the students write essays. You have them examine essays that have been generated by an LLM that very intentionally have small but subtle errors in them, and you try and get the students to find the errors and to correct the essay, basically. And so what it does is it teaches the students to have some skepticism of the stuff that they're reading. It's sort of like a literacy thing of read critically. It teaches critical reading, basically, and critical analysis. And then they update, they fix the essay, and then that's what they're graded against. And I think you could maybe do something similar with code review, as a like an exercise in school for people who are learning to do software development. Is you have LLMs generate plausible looking code and have the students fix it or find the problems with it, because there will invariably be for non-trivial things, there will be problems. At least last I checked, there will be problems. Maybe the models have gotten so good that they don't make problems anymore. But last I checked, they're still producing a lot of bugs. So I don't know. There's an idea. But yeah, do I use it? Not really. Not to help code. Yeah. Danny Colin says, still wastes more energy than simply taking real-world code. I mean, yeah, there's the energy, the cost to train these things is quite enormous. I don't know how much it costs to actually do the generation. It's possible, for example, I think Mozilla has a project called LlamaFile, and you can run these large language models locally. And so you can on my laptop do some token generation, and it's fairly responsive. And I don't know how much energy that takes. I do know that training these things takes an enormous quantity of energy. And so there's an ethical consideration there, especially, we're in a sort of a climate crisis here where renewable energy is something we're trying to pivot to. And, a lot of energy, all the gains in efficiency and we're trying to reduce our carbon footprint and whatnot. A lot of that is being offset, unfortunately, by the sudden interest in training these things on enormous quantities of data, and there's a vast energy expenditure. So there's an ethical quandary there. And then there's the developer energy in looking at the code that is generated and the time and energy it takes to review it. I actually think that, I'll go back to what I was saying before. It is an interesting idea to have students spend energy reviewing code generated by a machine that has problems in it. I think that's an interesting idea. Using a machine to generate a novel, a unique solution to some problem, and then either having the machine insert a subtle bug or having the instructor insert a subtle bug, and then having the student look for all of the defects that they can find. I think that's an interesting idea. And energy expenditure in terms of students' cognition in that case makes sense. It's working out their brains to think critically about the stuff that's being generated. Anyway, I'm getting distracted. I think we're ready to box this up and turn it into a patch. I need to document some stuff. And then I need to rebase some stuff. So the first thing I need to document is, first of all, I forgot. I have to await this. So let's run the test again. And then I have to document the early aborter. Okay, good. we're going to run the bytes, the characters from the archive stream through an intermediary transform stream that is going to cause an abort before the stream can complete. We'll do that by only passing part of the first chunk through and then aborting. Yeah, I like it. I like it. I'm glad we found a solution there. That was that the file is not never written to, is destroyed. That the recovery file is destroyed. Okay. Was there anything else I needed to... I don't know if there are any English teachers watching this. I'd be very curious to know what your thoughts are on having students grade essays generated by a machine. All right, so let's post this up for review. Make sure to destroy recovery.zip if decryption fails or does not complete. Decoding, decryption failed. Or just decryption, if decryption fails or does not complete. Backup reviewers. And then I have to rebase these. Rebase are here. I'm gonna rebase to this. Just tip. And once that's done, I'm going to run the tests again. And then we'll post for review. And then maybe we can look at that last that last bug that we or that other bug that we just talked about with the zip and testing the CRC testing. Okay, so that what I'm going to post up is probably up to about there. Actually, let's go all the way up to the tip. Build faster, build faster. Okay, let's run our tests. While it's running, oh, I see, I got some messages. Lots of messages from people. So test passed. Let's also run the marionette test, which actually does an end-to-end test. Let's do that. Make sure that that's all still working. Yep. Okay. And now we can post for review. OzFab submit. What are you coding? Asks Prestige90. Great question. So I am working on a mechanism that will, hopefully in the future, allow users to back up their current Firefox user profile into a portable file that can be recovered from on the same machine or moved to a different machine. It can be encrypted. It can be, if you encrypt it, you might want to, you could toss it up on like Dropbox or Google Drive or something and then transfer it to another machine and that sort of thing. So it's about user data portability. That's what I'm coding. What's in a user's profile? Bookmarks? It's everything. It's all of the user's state. So I say everything. It's most of what you care about. It is bookmarks. It's your passwords database. It's your history. It's all of your add-ons state. All of your customizations, all your preferences state, all of this stuff. It's everything you think of as yours whenever you're using Firefox. Hola Weedham Boys asks, have you seen Project Code Rush? Yes, I have. In fact, I did I watched it on a stream a few years back. I think it was like an anniversary stream. Was it like episode 300? No, I talked about... That was, we looked at ScumVM just as a celebration. Was it episode 200 that I watched Code Rush? Yeah. No, that was an advent of code. Was it 250? I know it was a milestone episode. Oh, and this one I watched an old episode together. Was it 350? That can't be right. Let's take a look at, let's see if I can find it. Project's Joy of Coding, episode guide, agendas, or episodes, grep, Code Rush. And episode 273 for some reason. Why was it episode 273? Oh, because it was the last episode of 2021. And that's why I decided, oh, let's have a special holiday episode. And I watched Code Rush. And I also played an old game that I made in QBasic when I was learning to program. And it was pretty cringy. I don't even think we were able to complete it. But I watched Code Rush. And if you're curious at all about what my thoughts were on Code Rush, you can watch it. Hola Hola Weedham Boy says, that's dank. Thank you. Thank you for saying it is dank. Can we watch you watching Code Rush? Yes. In this episode, on episode 273, you can watch me watch Code Rush. What's the link? Okay, fine. Let's see. Oh, the Aramo link is broken. I need to ask. I'll ask A. Korkendorfer about that. But in the meantime, let's find episode 273. Joy of Coding, episode 273. Special holiday episode. Here we go. Here's the link. Hola, hola, Weedham Boys. I just dropped it in the chat. Here. Let's see what I say. It's just very satisfying to suddenly see a through line to completion.
You'd be building with erector sets and Lego. Now, the structures that you build are in software.
One of the problems, I think, was that there was like an echo throughout
This is one of the first sort of the...
It's going to happen sometime between now and tomorrow afternoon.
In software development, there's always a bump in the road.
We just want to hear the Apple story.
Yeah, sorry about that. I didn't realize that at the time, but during the stream there was like an echo because I didn't have my headphones on. I don't know why I didn't have my headphones on. Was I streaming from the office? I'm not sure. Yeah, you're watching me watch past me watch Code Rush, so it's very meta. Light commute. I talk about.
I'm only gonna be running like.
I don't know if I end up recognizing anyone. I think I recognize a few people in the video. There's a fellow named Stuart Parmenter who's talked about here. He and I have met before. I think that's the only people. I think someone at Mozilla still, like, someone is in the stream or is in this video who still works at Mozilla. And there aren't many, but there are a few still around who are from like the Netscape days. And I think if they're like in the background of some shots. Anyways, very meta. Okay, so failed. Why not? I'm a rebase. Rebase fail halfway through. Why? Do it again. Why did you fail? Is he the super young kid who was contributing? Yeah, that's right. Stuart Parmenter, and he's not the only one. There were some other young people contributing early on. There's some young people contributing now. We have students hacking on Firefox all the time. If you're a student and you want to hack on Firefox, you're more than welcome to. The Code Tribute. This is where you find the good first bugs. codetribute.mozilla.org and get yourself a bug, and then we can work with you on it. During the documentary, you can see a developer writing a comment on a bug report, which is still there on bugzilla.mozilla.org. Hilarious. Yeah, I mean, except on extremely rare occasions, we don't delete bugs, we close bugs. And so, yeah, anything that was created back then would probably still be there. All right, so this stuff's getting put up for review. I think the last thing I'm going to do is let's take a look at this this zip reader test thing. I don't know how I'm going to write an automated test for this. I guess I could corrupt the zip file somehow. Yeah, if I like corrupt the zip file, it should fail in a particular way. I guess we could do that. So the way all of this stuff works, I kind of have to wait until this rebase is done. Sorry. Or whatever it's doing. Well, maybe not. Extract the compressed snapshot from the archive. And that's called by recover from backup archive. Then there's decompress recovery file. I guess I could expose decompress recovery file, make that public, and call it and test it. Oh, I guess I could like construct an archive that's got an invalid zip file instead of messing around with a valid zip file that got destroyed. I could like create a corrupted zip file. Right? Probably. That should be reasonable. Make sure. So this is what got posted for what we just wrote. Okay. And then I need to like reorganize the tree. There's a MozFab reorg. Yes. So that now we'll see that here it is. And now I just message my security engineering folk. Destroying the zip file if decryption fails or ends early is implemented in and that simultaneously once they're reviewed. Okay. The thing I wanted to do was putting in that check, the test. So let's put that coming from single file archives here. We'll do it there. And what I'll do is zip reader. We'll get the recovery archive. If recovery archive.test, and then what does that return? SI zip reader. Oh, sorry, it's back here. Test will. This doesn't return anything. So what is this? Zip reader. Test. Oh, it'll throw. That's what'll happen. Synthetic directory items. For test all items. There's an extract file to no out file, but I guess this is going to do your CRC check. So what we should do is try recovery test. Catch E. Lazy to log console error. Recovery. Compressed recovery file was corrupt. Then we will delete that decompressed recovery file. Recovery file path. Nor absent. I mean, it should still be there. Retry. Read only. True. And then we should throw new error, failed to decompress recovery file, or corrupt archive. Okay. Now the test. How will we test this? MJS, is this the new file extension for new JavaScript modules? Yes. Yeah, those are ES modules, MJS. And sys.mjs means that they're expected to be run with a higher level of privilege, usually in the parent process, but not always. Okay. Test backup service archive. This is where we're going to put our next test. I need to construct a zip. I need to mangle that zip somehow, and then attempt to decompress from it. So let us fake archive path, fake compressed file. We're going to create another fake compressed file. Okay, so same dealio as this. Corrupt archive, corrupt zip. Test that if the NSI zip reader fails the CRC check, that the decrypted, that the zip file is destroyed, and an exception is thrown. So we're going to create some fake archive, and instead of using that, we're going to create a staging path. We're going to create a real zip. Decompress recovery file. I'm going to need to make this public. Actually, since I'm just testing that, I don't need to do the whole like create an archive part. Don't need a sample. I don't need to do any of that stuff. Don't need a decryptor or anything. I just need a corrupt zip file. So I can actually get rid of most of this. So what I need to do is create a corrupt zip file. You know what I could do is just hand create one. So assert dot rejects await assert dot rejects, and then bs dot decompress recovery file. We're gonna give it the path to some corrupt const corrupt file path equals something. We'll figure that out. And then the path to decompress to, extraction path. We'll create a unique directory. Let recovery path, fake recovery path equals create unique directory, test, create archive, corrupt zip, sure. And then decompress at corrupt back file path, fake recovery path. This should reject. An error about being corrupt, and then we should assert that there are no children inside a fake recovery path. children equals await iutils get, was it children? Get children, fake recovery path, cert equal children dot length 0. Nothing was decompressed. Oh, I also need, because the file is going to be deleted, I can't just, I have to like move fake recovery file path, create unique directory, zip, source, corrupt zip, dest, and then I'm going to move, I'm going to copy, await iutils, copy, do get file. I need to like get our corrupt zip file, corrupt zip file equals do get file data / corrupt.zip, and then we're gonna say copy corrupt zip file dot path to path utils dot join fake recovery file path corrupt.zip, and we'll const corrupt zip source. We're going to move that to there. Fake recovery. So that's got to be down here. That's the destination. We assert that nothing was decompressed, and then assert okay, await iutils dot exists corrupt zip source, assert not exists, like the corrupt zip was deleted. Okay, and now I need to create a corrupt zip file. Schizophrenic web developer asks, am I from Canada? Yes. Asks, how many years have you been coding? Professionally, I would say 15 years? 15 years, roughly, give or take. Before that, I was in school for it. Before that, I was like a bit of a hobbyist. But professionally, about 13 to 15 years. It depends, give or take. Why do you use hash before function name to show that it's private or something like that, or read only? Yeah, that's a not a convention. That is part of the ES6 standard for private methods. You put a hash and it becomes private. And I've been making things a little bit more public so that I can test them, test the individual bits and pieces. Yeah, which maybe is a code smell, but. Well, so it is. So it goes. Okay, so let's create a corrupt zip file. We might actually have a pre-existing corrupt zip file in the tree. Yeah, test corrupt. This is a corrupt zip file. Test corrupt.zip. Libjar test unit test corrupt.zip. So what I'm going to do is I'm going to just support files it equals. I think there's a way I can do this. XPC shell.toml support files. Yeah. So basically, I want to go back from think tests. XPC shell, so I'm going back up one to tests, backup, components, browser. Okay, now we're in the root. I'm going to say modules. Is this the greatest? No, but it's what we're going to do. Test corrupt. Modules, libjar, test unit data, test corrupt.zip. Let's just try that for now. We could just copy the file. That's the other thing we could do. In fact, heck, let's just do that. Yeah, this is all too fragile. HG, copy, modules, libjar, test unit, data, test corrupt.zip to browser components, backup, test, XPC shell data, corrupt.zip. And then we just say support files, data, corrupt.zip. Put that quote in there. And then no matter what happens, I think I'm going to call it there. I think the episode's basically done at this point. If you enjoyed the stream, let me know what you thought. I'm eager to hear from you. There is a form. It's here under Rate This Episode. And you can follow along. Well, not follow along. You can ask me questions. You can give me feedback on what you thought of the stream. Maybe you liked it. Maybe you thought it was awful. Maybe there's stuff I should do more of. Maybe there's stuff I should do less of. Hey, that worked. That worked. We're done aborting early. Extraction should have been automatically destroyed. And then compressed recovery file was corrupt. That's good. Nothing was decompressed. Corrupt zip was deleted. Amazing. Amazing. I'm pretty happy. Got some good tests written there. Yeah, feedback link. Here it is. Feedback link. There it is in the chat. Is there more you want to see? Is there less you want to see? Is there something different I should do? Do you have any questions I can try and answer during the next stream? I'll do my best. For people who ask questions, I'll do my best to answer them. But if I don't have the answer, I don't have the answer. But I'll do my best to answer them. And yeah, send stuff in. I read everything that comes in. All right. Well, thanks so much for watching episode 369 of The Joy of Coding. I hope you have yourselves a great week. I think I'm streaming next week. I might not be. I might actually, I'm not entirely certain. There might be an overlapping meeting. I still need to look into that. But you can follow me on Mozilla.social if you want to hear updates. That'll be your best bet. mconley@mozilla.social. And thanks again. And we'll hopefully see you next week or sometime after that. Take care, everybody. Bye-bye.
The joy of coding.
See ya.